Day 358 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 32, longest valid parentheses. The difficulty level is hard, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a string containing just the characters open parentheses and close parentheses, return the length of the longest valid well-formed parentheses substring. So first, let's take a look at what a substring is. It says a substring is a contiguous, non-empty sequence of characters within the string. So it sounds simple enough, y'all, but let's go ahead and look at these examples just to make sure we're doing this problem correctly. So in example 1, we have the input s equals a string. We have the open parentheses, close parentheses. Output is 2. Explanation says the longest valid parentheses substring is the open parentheses and close parentheses right here. So this is the longest valid parentheses substring, right? So the substring right here, it says a substring is a contiguous non-empty sequence of characters within the string. So as you can see, this is a contiguous sequence of non-empty characters, right? And in this case, it's just two characters, the open parentheses and the closed parentheses, so the output is 2. So we want it to be a valid parentheses, meaning for the parentheses to be valid, it has to be open and closed. It can't be like this, open. That's not a valid parentheses. That's not how parentheses work. You have to open the parentheses and then you have to close the parentheses. Where in this right here, where it's highlighted in blue, is 2 open parentheses, and that doesn't count as a valid parentheses. That's not valid because that's not how parentheses work. This is how parentheses work, and that's what makes it valid. So let's go ahead and take a look at example 2, where there's a little bit more parentheses for us to look at and work with to more fully understand the problem. So in example 2, we have the input s equals a closed parentheses, open parentheses, closed parentheses, open parentheses, close parentheses, close parentheses. This time the output is 4. Explanation says the longest valid parentheses substring is the open parentheses, close parentheses, open parentheses, close parentheses. So as you can see, this substring right here, once again, it's a contiguous non-empty sequence of characters within a string. So as you can see, this is a contiguous substring or non-empty substring of valid parentheses, right? So we open parentheses, then we close them. That's one valid parentheses, but that's 2 characters. Then we open the parentheses and close the parentheses again. That's another valid parentheses, and that's 2 more characters. So in the final output, we have 4 characters, one right here, one right here, one right here, and one right here. That's 4 characters all together. So the output is 4. Now, once again, as you can see, this is not a valid parenthesis. Why? Because it's a closed parentheses and then an open parentheses. That's not how it works. It has to be an open parentheses and then a closed parentheses for it to be a valid parentheses. Same right here. This is 2 closed parentheses in a row. That's not how parentheses work. That's not a valid parentheses, right? We need an open, close, parentheses. And in this case, we have open, close, 2 times, which gives us a total of 4 characters, and that's why the output is 4. So let's go ahead and take a look at example 3, where they might try to throw a trick question our way with the blank string. And in this case, the input in example 3, we have the input s equals a blank string, output is 0 because there are no characters to even there is no substring, there are no characters, so we could just return 0 because there are no valid parentheses in this entire input, right? So we just return 0 because there's no valid parentheses in the input. So now that we understand the problem, y'all, let's get into the fun part, the actual solution. Solution's not that difficult or long, so we should get through it fairly quickly. So let's get started. Now, Excuse me, y'all. The first thing we need to do is we need to check if the input string is empty, and if yes, we could just return 0, similar to how it is in example 3, right? So to handle that, we'll just use a guard statement. We'll say guard exclamation point s dot is empty. So what this exclamation point mean is s is not empty. If so, that's why we put the exclamation point. So it's saying guard s is not empty with that exclamation point. Then we could just say else. So if it is empty, we could just return 0. Boom. Now we need to initialize our result, and we need to initialize our result or our count, and we need to initialize our stat. So for that, we could just come right here. We're going to declare a variable called count, and that's going to keep count of the number of parentheses, so, or valid parentheses. So we say count equals 0. We can start that at 0. Then we can declare another variable called stack, and we can set that equal to, open up the square brackets, -1, just for the base case. Boom. Now we're going to come right here. We're going to say for, open up the parentheses, I, comma, ch, n, s dot enumerated, put the parentheses. See how this valid parentheses work? Open, close, boom. So what this enumerated is going to do is it's going to get us the index of each character and the character itself, right? So that's why the enumerated is important, because it's going to get us the index and the character when we're looping through S. Now we're going to say guard ch does not equal, open up the question mark, so does not equal a open parentheses, then, or we could say else. So if it does equal that, then we could just say stack dot append square bracket I, which is going to append the index for us, right? So if the character is in open parentheses, it's going to push its index into the stack. Then we could just come right here and we could say continue. Boom. Now we're going to come right here underneath that guard, and we're going to say guard stack dot count is greater than 1. Else, so if it's not greater than 1, right, then that means the stack only has the base index, and we need to update the current index. So to do that, to update the current index, we're going to say stack square bracket 0. We're going to set that equal to I. Boom. Then we can come underneath that and we can just say continue. Boom. Now we need to pop the last open parentheses index, since if we found a closing parentheses that matches it. So we're going to say, come right here underneath this, and we're going to say stack dot remove last, and open up the parentheses. And open and close the parentheses. Boom. Then we need to update the max valid length if the current is longer. So for that, we could just say count equals max, open up the parentheses. We're going to say count, comma, I minus stack dot last. And whichever one is larger, that's what's going to be returned in count. Then we just need to return the length of the longest valid parentheses substring, or return the count. So for that, we come underneath this and we can say return count, just like that, y'all. That should be all she wrote. Told y'all it wasn't that much code. Let's go ahead and give it a run before we submit it, though. Make sure it's still accepted. Ooh, what's a must be unwrapped. Sorry, y'all. Need to put a parentheses right here. Boom, that should unwrap it. So let's run it again. And it's accepted. So let's go ahead and submit it and make sure it's still accepted after we submit it. Let's see. Ooh, 2 milliseconds beats 54.26% of users. Not too bad. We could get those numbers up, but as y'all know right now, we just want to be able to solve the problem that is presented to us. And I feel like this is a good, easy to understand solution for that, because if you don't understand the solution, then you probably didn't learn anything. Excuse me, y'all, and that's not what we want. We're all here to learn. We're all here to be better leak coders, and that's why it's important to understand the solution. So I picked the solution that I felt that was easy to understand. We'll continue down our LeetCode journey and get these numbers up as we get better. But right now, I feel like this is a good solution and a good place to be. You know, it's a hard problem, so we're not going to be the best that we're not going to just be the best out the gate. It takes time, practice, patience, consistency to be the best. And that's what we're here for, to put in the work and do the LeetCode problems every day. So with that being said, y'all, make sure you get one more look at the code. Read it, learn it, love it, understand what's going on. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.